Thank you. Thanks for having me. I hope you're having a good conference. It's good to see everyone out. And I hope you're enjoying the content and you're learning things and seeing what's possible. And hopefully I'll be able to show you one of the new things that's coming out for Compendium at Enterprise R6. And it's the new and improved HTTP support from OSGI. And the specification is the HTTP Whiteboard. And I think it's how web apps should have been built in the first place. So this is a brief outline of what I'm going to go through, but I'll just dive right in. So HTTP Whiteboard started off as an RFC called HTTP Service Updates. Basically what it was, the old HTTP spec was born from Servlet 2.1 era, which was very limited and didn't have support for filters, didn't have support for event listeners, and was generally, pretty useful, but because of these limitations, was pretty. It was limiting. So this evolved into a specification, a different spec. Actually, well, it's evolved to a spec that we're calling now HTTP Whiteboard specification. It's going to be section 140. So when you're looking in the new documents, you'll be looking for section 140. And what it did, instead of making a whole bunch of changes like we had originally thought of making to the original HTTP service, that is remaining completely unchanged. So it's what we're doing is adding new functionality to extend that. So everything else will stay the same for the imperative API, and the HTTP Whiteboard is going to add completely new functionality on top of that. And so it's bringing in the whiteboard programming model. Does everyone here know what the whiteboard model is? Okay. So the whiteboard model, for those who don't know what it is basically that you leave the job of creation of the component or to registration of the component to someone else effectively. And this is a very powerful model. And it's the model that you'll see when we're using specifications like declarative services, where you're basically defining a component, you're putting some annotations on it, and you basically fire and forget. And at some point, the system comes into play, builds a concrete object from that, does all the wiring, and you're off to the races. It has a well-defined life cycle, which you can plug in through initialization and activation of those components. And so you can basically interact with the system that way. And this is a much easier, much more elegant programming model than imperative APIs, where the more API you call, the more chance you have of making mistakes in the use of that API. So if you limit that, you can actually save a whole bunch of boilerplate code and, again, places where you can add bugs to your system. So what were the design goals for the new spec? Well, minimally, we wanted to bring it up to at least Servlet 3.0 level of the servlet specification, of the Java EE servlet specification. We wanted to add a whole bunch of missing things like multiple URLs for servlets, servlet filters, event listeners, error pages, and that stuff. We wanted to clarify some relationships in the context that joins these objects together. On the servlet spec side, that's the servlet context, and on the HTTP side, on the OSGI HTTP service side, we had this HTTP context object, and sometimes it wasn't very clear how those two mapped to each other, and there was a conflict of how that was defined. So we wanted to clarify that. And then we had this other specs were evolving into this. Having this other capability, which was to introspect the system to see what's going on. And so a specification called the Dto specification had been tacked on during core R6, I believe, Peter. So now in core R6, there's this model where you can ask the implementation for its state. And that state is represented in DTO objects, which are easily serializable and very, very powerful. So we wanted to add that to the HTTP spec because it's important to be able to see what the running system actually looks like, as opposed to leaving it to chance. And then we also wanted to bring up a capability namespace for the HTTP service, so you could actually state inside your manifest that you have a dependency on this and your bundle requires it to run. So let's get down to it. This, if you haven't discovered yet that the OSGI Alliance is promoting heavily the use of DS in favor of other types of component frameworks in OSGI, you're probably missing something. Declarative services is arguably the model that I think we see everyone promoting now. So if you haven't started using this or considering it yet for your projects, you must do so, because you will save a lot of energy and a lot of head pounding. So here is how I define the core object, which is going to unify a whole bunch of my HTTP objects. And the HTTP objects are just the ones I mentioned before: servlets, filters, event listeners, and resources. So this would map effectively to a servlet context, right? So it's a servlet context helper, and all I'm defining here is a name for my context and where it's going to sit in my URI subset. Okay, so here I'm saying I want a context to live at the root path, and that context is just the default context. And this is literally the entire object. Now I want to add a servlet to this container. Literally the entire object. It's a sample servlet, it's a hello world servlet, it's a default servlet because it's being mapped to the root URI. In other words, if no other servlet matches any of the path, any of the URI, it goes to this servlet. Nothing more to say. I'm going to be done this presentation very quick. Okay. Resources. We want to serve resources, static resources, CSS, JavaScript, plain HTML files, text files, binary downloads, whatever. This is literally my object. I'm mapping a space. A prefix is the mapping within my bundle that I'm targeting. So in this case, I'm saying that inside the meta-inf resources folder, or sorry, let me flip that around. I have a pattern that says any URI that matches resources / and whatever is going to be mapped into the meta-inf resources directory inside my bundle. Done. Yeah. No, it's just a plain object. Because the object is in fact ignored. The only relevant information here is the configuration, are the properties. So the resource servlet is actually provided by the implementation. It's searching for on the property names. It's a listener that's only searching on the property names. It needs no type. No. This creates a service. It just creates a service with. Sorry, what I'm forgetting here is that there should be a service stating of type object. Yes. Yeah. That's what I missed here. My mistake. Thank you. Thank you. Yeah. So correction, this would be a service of type object. So basically the object is thrown away and the only relevant part are the properties. And then a filter. Again, just property. A property saying whiteboard filter pattern. My pattern is /star. And I'm creating a filter. This filter literally does nothing except continue the filter chain. You can do pre-post, you know, it's a filter. We're used to those. And then finally, a servlet context listener. This is just one of the event listener types that are supported, but this is, again, literally an implementation. There is no other properties here other than a component. And so this will be handed to the default context by default because it's not stating. So I'm just going to go back for reference here. Any one of these implementations on top of this, let me go back to the servlet context helper. So how do I assemble or create an assembly? So let me start over. All of these objects would share the context. In other words, if in my object, let's say my servlet, I get the servlet context and I put an attribute in the servlet context. All of these objects having been taking place and collaborating on the same servlet context, the default one in this case, they would share the context at that point. So the filter would see the servlet context attributes in the default context and so on. But what if I want to make a different assembly at a different URI? I want to have app A. So I want to /app A, and then I want filters and servlets and event listeners inside of that context. I would just create a new servlet context helper with a different context path and a name. And then when I create my servlet, there's another attribute that I would add here, another property, which would be HTTP Whiteboard Servlet selector, which would state the name, and then it would basically join that assembly. So you can create as many different contexts as you want. So you can boot entire applications inside of a URI. Unlike what you would have to do in a Java servlet container, you would have to put all of your objects inside one web application, and that would be mounted at a context path. Here you can do the opposite. You can say, I'm defining a context path, and by the way, I want all of these objects to be an assembly under that context path. So you can reuse and reassemble your application at will, however you want, by just saying which objects go with you know, which should be grouped together. So it's a very, very, very powerful model. Okay, so we have error pages. Again, error pages, you know, exception or a code, HTTP response code. DTOs. So here, I went an extra mile and did the actual implementation of what a servlet would output the DTO of the HTTP Whiteboard implementation. So this is a servlet. It's mapped to the DTO URI. And it's using a reference. It's creating a reference on the HTTP service runtime. So it's saying, okay, don't initialize this component without the runtime, which it couldn't because it's an HTTP servlet, and so it wouldn't start anyways, but I'm still declaring I want that object. And so in my service, I'm going to use the object, and I'm just going to literally write the toString of the getDTO out. Because the DTO, by default, its toString method prints JSON. By default, that's the syntax defined by the Dto specification, which is really cool. I just toString anything I want to print, and I automatically get a really, really basic web service out of it, which is really, really cool. So literally, this provides me with my foundation for doing a quick demo. So sample servlets, and I have my sample DTO report servlet. It's identical to the one I had on my slide. And I'm going to go over here. And what I have is I created a, this is neither BND tools, neither PDE. It's a bastardization of a whole bunch of different things. So, but basically what I did is I created it's just a target runtime which has the minimal OSGI R6 the runtime Equinox. It has Jetty. It has the HTTP service, and then just that. I'm just going to run it through run as OSGI framework. I'm going to wait for it to boot. And here I see I have my Go shell interface, which I added. My components initialize. One of my components had some system outs. And this is running. Here, that's my basic hello world servlet. We're even being super crazy, and this is running a full-blown JSP implementation inside of OSGI. It's compiling at runtime. You know, it works. Why would you do that? It's a good question. And finally, DTO. My DTO is spitting out the state of my HTTP runtime. I can introspect and I can query on the objects and see what's going on. And that's pretty much it. Any questions? It's a beautiful thing. I can actually show you, this is implementation that I'm running right now, is the Equinox implementation, which I'm maintaining for the Eclipse Foundation. And what did I want to show here? The rest of my slides. So I'm very excited with this very simple specification. It's very powerful, and it's a beautiful model to build with. It's the way web applications should have been built from the start, because you get to assemble as you need. You don't have to build big monoliths, because web applications tend to just form into monoliths. And this is, there's a link here to the R6 early draft. If you don't know where that is, that's available on the OSGI website. You can download the early drafts. If you have feedback, we would really love to have that. You're encouraged to comment back, to look at the spec, but do so quickly, because this spec is just about ready to be, is almost fully baked. And if you have any feedback, it would be the, you know, right now would be the time to give it. So just to pitch again for the Eclipse, this is now in Mars M3, which is due on Friday, so you can actually play with a real implementation of this, which is a draft of the spec. Again, there's a little time left for feedback, but I just wanted to show that this is not just a small implementation and it's not fully baked. I'm especially proud to say that if you were to go to the Eclipse help and you load the help content, there, this is running on the new HTTP spec. So the new HTTP Equinox implementation has both the legacy, and it's fully compatible, and now all of the Eclipse documentation is running on this new implementation, which I'm especially proud of, because it means I'm helping every Eclipse developer in the world. That's not the debate there. So, any questions? Yeah.
So the info center is gone and replaced by the release 6 HTTP implementation. There's no need for a special info center application regarding the help.
That's a good question. All I know is that the new implementation is just replacing the old one, and basically it was a turnkey. It's because it's still supporting the old spec, so that stuff is still built against the old imperative API. But because it's compatible, it's just running that way. So, yeah.
Which bindings do I need to put it onto the list?
The only thing you need actually is here. This is, if I can show you that the full implementation of an OSGI stack with, it's not a stack, right? Sorry, forgive me, it's not a stack. So, this is my whole assembly of bundles. Other is the root container is the basic stuff, config admin. It's not really necessary. Actually, it's a dependency of Jetty. But I have, this is my base, the OSGI runtime, which is Equinox. I have added Felix and Go. This is all the non-HTTP related stuff. And the HTTP bundles, Equinox now delivers Jetty 9, which is cool. So it's Jetty 9. And then see that one bundle at the top? That's this API spec. That's just a homegrown bundle of it. And then Eclipse, Eclipse, Equinox, HTTP Servlet is the only bundle you need with Jetty. So you need Jetty, and then you need the servlet, the HTTP Servlet bundle. And that's it. This whole assembly is really sweet, not including JSP, runs in at 3.6 megabytes. So you have a full-blown HTTP 3 minimally compatible. We actually, for the Equinox implementation, we're going to start testing all the 3.1 WebSocket stuff to make sure that all works in the container. That'll be 3.6 megabyte HTTP server runtime with all of the WebSocket stuff running through OSGI using DS as your programming model. Brilliant.
The context listener didn't have any properties at all, so how does it match the context then? It also doesn't have a
It's just mapping by default to default.
default is really the magic.
Yeah. It's just going to go to the default. And if you provide a name, it'll connect to the name. And if it doesn't match anything, let's say I create a component and I say I want to connect to this name, and when the HTTP Whiteboard specification says or tries to look at where that should be placed, then there's no match, there's no context by that name, one of two things will happen. If it's a default, if it's a default for the bundle, it will create a new context for it. If it's a name that, because we're using a factory, we're using a service factory for the default. So if you're saying default, it's going to get a service factory. If you give a different name and it's not created already, it's going to actually put it as in the error DTOs. So you're going to see in the error DTO that you have some objects which were not mapped to any servlet context. So that would be your way of determining that I have objects that aren't actually in use or being applied anywhere. On the other hand, you're able to say, you're able to use service scopes. Which is the service scope for creating new instances on each call again? Prototype scope. So if you're using prototype scope, you'll actually get a different object mapping to every servlet context, potentially. So let's say I have a servlet filter and I want to apply it across the board. I don't know, a gzip filter. You don't want to create a new gzip filter object service for every servlet context. You're just registering a gzip filter across the board, everybody should use it. If you provide no name, it's going to map to everything if it's a prototype scope. Every servlet context will pull an instance of it, so you can reuse them. Or is it actually a regex that does that? It's a good question. I think if they provide no name, it will be transparently mapped to everybody if you use prototype scope. So the session will be mapped individually per servlet context. So if you'll have a servlet context, it will map to a session scope for that servlet context. You'll have to get it through the servlet API. But what the relationship will be is that if you get a session scope, it'll map to a servlet context. So everything that's mapped to that servlet context will get the same session, let's say. Right? Does that make sense? So the session is unique per servlet context, per user, per login session, right? Not clear? Any more questions? I highly recommend that you look at the spec. It's very informative, and I make this recommendation across the board. If you have any doubts whatsoever, do not rely on just plain old Google searches, because right now there's a tendency of being a relative void with respect to how new OSGI or recent OSGI stuff has been documented. So when you Google for stuff, generally what you're finding is about 4 to 5 year old information. So how do you solve that problem? Just read the spec. Get the spec for the version that you're using, read the spec. It generally has code fragments in there. That's the best place to go. So if you have any doubts, just read the spec. It's not that dry. It's actually really good.